Lesson 8-6, quadratic equations, perfect squares. So we first want to discuss what a perfect square trinomial is. A perfect square trinomials are squares of binomials. So for a trinomial to be factorable as a perfect square, there are three conditions that must be satisfied. The first and last terms must be perfect squares, and the middle term must be 2 times the square root of the first and last term. So let's look at an example of 16x squared plus 24x plus 9. So the first term and the last term are perfect squares, which is the first kind of requirement. And then it says the middle term must be twice the product of the square roots of the first and the last term. So the square root of the first term is 4x, and the square root of the last term is 3. So if you multiply both of those together, you get 12, and then if you twice 12 is 24. So this is an example of a trinomial that is factorable. Pause the video to try a few examples. So for example number 1, we have 4y squared plus 12y plus 9. So we first want to find out, is the first term a perfect square? It is. Is the last term a perfect square? It is. So now you have to determine, is the middle term 2 times the square root of each? Well, the square root of 4y squared would be 2y, and then the square root of 9 would be 3. 3 times 2y would be 6y, times 2 would be 12y. So we would say that yes, this is factorable. Then we have 9x squared minus 6x plus 4. 9 is a perfect square. 4 is a perfect square. So the square of each of these is 3x times 2 multiplied by 2, which would give us 12. So this one would not be factorable. Okay, so we're going to discuss just real quickly some of the factoring methods, and then we're going to look at putting some of them into place. So where it says here, step 1, you factor out the greatest common factor. You do this no matter how many terms you have. So no matter how many terms are in the trinomial, you want to factor out the greatest common factor. Step 2, you can check for a difference of squares or a perfect square. This is when you have 2 or 3 terms. So if you're kind of in that 2 and 3 term range, you can check for a difference of squares or see if it is a perfect trinomial. And then lastly, if you have 3 or 4 terms, you can apply the factoring patterns, which is the x squared plus bx plus c, or the ax squared plus bx plus c that you've learned previously in the chapter, or by factor out by grouping. So there's a variety of different methods that we can use when factoring trinomials, and we're going to look at a few of them along the way. So let's look at the first example. We have 5x squared minus 80. So we know that for step 1, we're going to factor out the greatest common factor. So we first want to take out the 5, because we know that that's what goes into both of them. And so if we take out the 5, we have 5x squared minus 80. So if we take out the 5, we have 5x squared minus 16. So now you would go on to step 2, because you have more than one term. And so step 2 is that since there are 2 terms, you check for a difference of squares. So that means that you're going to now take this 5x squared minus 16, and you're going to factor it out to 5 times x minus 4 times x plus 4. Anytime that you are not able to factor a polynomial, you want to write that it is prime. So this is an example of a problem only having two terms. You would only go to that step 2 because we know that we get the step 2 when we have 2 or 3 terms. Next, we're going to look at an example of how we get to all 3 steps. So for this example, we have 9x squared minus 6x minus 35. You first want to find the greatest common factor for all of these, which in this case would be 1. So we're not really going to worry about kind of factoring anything out because they don't really have much in common. Since 35 is not a perfect square, because 9 is, so that one checked out for your perfect square part of your step 2. Step 1 was greatest common factor, step 2 is perfect squares, or factoring. Number 9 is a perfect square, but 35 is not. So we know that we have to go on to step 3. So now we want to factor this out using the pattern ax squared plus bx plus c, because that's the form that it's written in. So to do that, remember this is where we multiply our first number and our last number. So we need to find two numbers that multiply together to give us negative 315, but that also have a sum of negative 6. So when we do that, we have 15 and negative 21 are our numbers. So 15 and negative 21. So let's write this equation out. So we would have 9x squared plus 15x minus 21x minus 35. So now from here is where you would group the terms that have common factors. So we are going to group together the 9x squared and the 15x, and then we're going to factor together, we're actually going to put a plus sign in between these two, and we're going to factor in negative 21x minus 35. The reason I put in a plus sign is because I actually want the negative to go with the 21, and so we're just going to imagine that everything is multiplied by a positive because everything inside is negative. If I were to leave the negative out front, it would change my numbers. So from here, I'm now going to factor out the greatest common factor from each group. For my first group, my greatest common factor would be 3. So this would become 3, it would actually be 3x, I'm sorry. So this would become 3x plus 5 plus, and over here I can factor out a negative 7. And so this would be 3x plus 5. So then I would rewrite it as 3x minus 7 times 3x plus 5. So that would be my factored trinomial. Pause the video to try the example below. So we first want to find the greatest common factor between all of these numbers. And if we just kind of look at them, you can see that we do not have a greatest common factor other than 1, so we're going to leave it the same. Then we want to determine if they are perfect squares. We look at 12, and 12 is not a perfect square, which means that we're going to be factoring this out as ax squared plus bx plus c. So I need to find two numbers that multiply together, or I'm sorry, that 12 times negative 25 is going to give us negative 300. So I need to find two numbers that multiply together to give us negative 300, but that also add to give us 5. So we know that this would be 15 and 20, and the 15 would be the negative. So we're going to write it out. 12x squared minus 15x plus 20x minus 25. So I'm going to group them together, and I'm going to take out the greatest common factor. So for this one, it would be 3x. So we would have 4x minus 5. And over here, I would factor out a 5 and get 4x minus 5. So my final answer would be 3x plus 5 times 4x minus 5. So we're going to take a look at solving equations with repeated factors. And so when you have an equation that's like this, you always want to subtract it so that it's not equal to something. So I'm going to subtract and get it equal to 0. So minus 64 to equal 0. I'm sorry, add 64 to equal 0. And then from here, we're now going to start kind of seeing what we're putting it in form of. We do recognize that 9x squared minus 48x plus 64 is a perfect square trinomial. So you want to factor out the perfect square. So that means that you're going to take out of there what there is that is perfect. So to do that, you want to look at your first number and your last number. So your first number, if you squared it, would be 3x to get you 9x squared. And then in order to get 64, you would have to square 8. But you also have to get a negative 48, which means you have to make this 8 negative. So you would square that. So then you want to set, you're writing this as two factors. So 3x minus 8 times 3x minus 8 equals 0. And you're just going to set one of those equal to 0 because it's going to get you the same thing. So 3x minus 8 equals 0. You add 8 to both sides. It's going to give you 3x equals 8. Then you divide both sides by 3. So that means that x equals 8 over 3. So the last part of this section that we're going to talk about is the square root property. And what that means is that for any number n that is greater than 0, if x squared is equal to n, then x equals the plus or minus the square root of n. And so that means that to solve a quadratic equation in the form of x squared equals n, you take the square root of each side. So for example, we have x squared equals 25. Well, to figure out what x is, you take the square root of both sides. So that would mean that x is equal to plus or minus, oh, sorry, I need to erase that, plus or minus, kind of got ahead of myself there, 5. Now the reason that we know that it is plus or minus is because you could do positive 5 times positive 5 and it'll still give you 25, or you can do negative 5 times negative 5 and get 25. So let's take a look at an example of something you would see. You have y minus 6 squared equals 81. So for this, you're going to actually take the square root, using the square root property of both sides. And so you're going to have y minus 6 equals the plus or minus square root of 81. Well, we know that y minus 6 equals plus or minus 9. So now you're going to add 6 to both sides. So you get 6 plus or minus 9. And then you need to solve both ways. So you need to do 6 minus 9, which is 3, or negative 3, or you need to do 6 plus 9 and get 15. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video.